Here's a question that looks technical but actually tests how deeply you understand what's happening under Python's hood. How is memory managed in Python? Now, the good news is Python manages most of it for you automatically. But under the surface, it's doing 3 really smart things to keep your code efficient. First, it uses reference counting, which means Python keeps track of how many variables point to a particular object in memory. When that count drops to 0, meaning nothing's using it anymore, Python automatically frees it. Second, it has garbage collection, which steps in for more complex cases, like when 2 objects reference each other and can't be freed by counting alone. And third, Python uses memory pools, more and more VO, a built-in system that recycles small chunks of memory efficiently, so objects are created and destroyed faster. In an interview, what they're really testing here isn't memorization, it's whether you understand object life cycles, memory leaks, and how to keep large-scale pipelines running efficiently without crashing. Let's see how this works in practice. In Python, every object keeps a small internal counter. It's like a popularity score. Each time you assign that object to a new variable, the score goes up. When one of those variables is deleted or goes out of scope, the score drops. Once it hits 0, Python knows the object isn't needed anymore, so it automatically clears that memory. But here's the tricky part. Sometimes 2 objects can keep referencing each other, forming what's called a circular reference. When that happens, the reference count never reaches 0, even though nothing else in your code is using those objects. For example, imagine 2 simple nodes, A and B, that each hold a reference to the other. Even after your function ends, they're still keeping each other alive. That's where Python's garbage collector comes in. It periodically checks for these loops and cleans them up safely. Now, let's make it real. Here's how I'd explain this in an interview with a story. In one of my recommendation pipeline projects, we were processing over 10 million records daily. I noticed the system memory kept growing after each batch run, a classic sign of a memory leak. Using sys.getrefcount, I found out that cached data frames were holding circular references through custom wrapper classes. Once I understood how Python's reference counting and garbage collector worked, I added proper cleanup inside our destructor methods and switched to weak references for observer patterns. That small fix reduced our memory footprint from 16 gigabytes to just 4, and the system ran 3 times faster without restarts. That's a confident answer. It shows you don't just know Python's memory model, you can use it strategically to debug, optimize, and scale data pipelines in production.